In this video, we are going to investigate two more differentiation formulas. And remember kind of the big picture idea. Using the definition of the derivative, we've seen to be, time-consuming, rather tedious. And fortunately for us, there are these rules of differentiation that make our life a bit easier. Two more such rules are the product rule and the quotient rule. What the product rule tells us is if we have a product and we want to differentiate it, so f times g prime, this is going to be in words the derivative of the first times the second function plus the first times the derivative of the second. And I realize it may be the most intuitive thing in the world to say that fg prime should be f prime g prime, but it just is not the case that that is true. The product rule tells us that fg prime is the derivative of the first times the second plus the first times the derivative of the second. Likewise for the quotient rule, if you have a function f over a function g and you want to differentiate it, you get the bottom function times the derivative of the top minus the top function times the derivative of the bottom over the bottom squared. Now, a catchy way that I remember this is I think of the f function as being the high function, the g as being the low. And in words, I would say low d high minus high d low over low squared. So let's go ahead and apply these two formulas to a few examples. So the first function we would like to differentiate is x to the fourth minus 1 times x squared plus 1. This is a product, so we are going to use the product rule. And if you want to make the comparison to the previous slide, we're thinking you have your first function, x to the fourth minus 1, and your second function, x squared plus 1. So the product rule tells us that we take the derivative of the first, so we'll say the derivative of x to the fourth minus 1 times the second function plus the first function times the derivative of the second. So what the product rule really does for us, and we can see it very clearly here, is it takes this maybe larger function and says instead of differentiating it all at once, it's breaking it down in terms of maybe some simpler derivatives for us to evaluate. So evaluating the first derivative using the sum rule that we have previously, we would have the derivative of x to the fourth, which by the power rule is 4x cubed, and then we subtract away from that the derivative of 1. And the derivative of a constant is 0. So the 0 here is the derivative of 1, and the derivative of a constant is 0. This is times the second function, x squared plus 1, plus the first function, and then we multiply it by the derivative of the second. Using the sum rule, we can take the derivative of x squared plus the derivative of 1. By the power rule, the derivative of x squared is 2x to the first plus 0. Simplifying just slightly here, I'm going to write this as 4x cubed times x squared plus 1 plus x to the fourth minus 1 times 2x. And in terms of simplifying, this is a step where I would usually stop. And I like seeing it in this form because I very clearly see the derivative of the first times the second plus the first times the derivative of the second. So in this last example, we will differentiate x minus 1 over x plus 1. And we notice that it's a it's a quotient of functions. So we are going to use the quotient rule. So our first step is going to be just to write out what the quotient rule tells us. It tells us in words low d high, so the derivative of the top function, minus high d low, that is the derivative of the bottom function, all divided by low squared. So the function in the bottom squared. And I think it's really important to write out the quotient rule in terms of these derivatives that have yet to be evaluated, because what that's doing is taking the problem and breaking it down in terms of easier steps. So we very clearly see which derivatives need to be calculated. Additionally, the more we try to do in our head, the more likely we're going to be to make smaller, maybe sillier mistakes that we wouldn't make if we were to write out all of these steps. So let's go ahead and evaluate the resulting derivatives. So the derivative of x minus 1. Well, let me to the side calculate a derivative. If you wanted to calculate the derivative of x, you would say, well, the derivative of x, that's really x to the first power. So the power rule tells you the 1 comes out front, and the new power of x is 1 less than it previously was, x to the 0. So the derivative of x is simply the number 1. A similar formula would tell us that if you have the derivative of any constant you would like times x, you pull the constant out front, and then what remains is the derivative of x, which you already said is 1. So the derivative of x is 1, the derivative of any constant times x is that constant. So the derivative of x minus 1 is going to be the derivative of x, which is 1, minus the derivative of 1, which is 0. Then going across the top, we have an x minus 1, which remains, and we have the derivative of x plus 1. So that would be the derivative of x plus the derivative of 1. And this is all divided by x plus 1 squared. And let's go ahead and just do a simplification here. We have in the top x plus 1 times 1, so the first term is x plus 1. We're subtracting away from it x minus 1 times 1. So when that minus sign distributes, it's going to be a minus x plus 1. So the positive x and the negative x are going to cancel, and we are simply left with the number 2 in the numerator.